So here, let's take a look at some more equations involving logarithms. So this first one here, we have log base 2 of x minus 7 is equal to 3 minus log base 2 of x minus 5. Okay, so let's go ahead and see if we can use the log rules that we have established before to see if we can solve this. So let's get all of the logs with x's in them on one side. So we can start by adding log base 2 of x minus 5 to both sides. So these will cancel, and we'll end up with log base 2 of x minus 7 plus log base 2 of x minus 5 is equal to 3. Okay? So if we look at our product rule, we can go ahead and combine these logs into one log, and we'll get log base 2 of x minus 7 times x minus 5 is equal to 3. All right? So now we have our usual rule for logs here. So we can think of this as 2 to the third is equal to x minus 7 times x minus 5. Or we can think of this as 8 is equal to, and once we FOIL these out, we will have x squared minus 5x minus 7x plus 35. Okay? So if we take 8 away from both sides, we will end up with x squared minus 12x plus 27. Okay? So now I want to is equal to 0. So now I want to see if we can find two numbers that multiply together to give us 27, positive 27, and add together to give us negative 12. So I'm thinking negative 9 and negative 3. Okay? So we can rewrite this as x minus 9 times x minus 3 is equal to 0. Looks like we're going to need a little more space here. Okay? So that means that our possible solutions here are x equals 9 and x equals 3. But we're not quite done yet because we have to check that both of these solutions would make sense. Okay? So let's start with x equals 9. Okay? So x equals 9. All right? So we have log base 2 of 9 minus 7 is equal to 3 minus log base 2 of 9 minus 5. And this is equal to log base 2 of 2 should be equal to 3 minus log base 2 of 4. Okay, but let's go ahead and add log base 2 of 4 to both sides. So we should get that log base 2 of 2 plus log base 2 of 4 is equal to 3. Okay, so let's go ahead and use our product rule. And we have log base 2 of 2 times 4, which is 8, should be equal to 3. Or 2 to the third equals 8, which is true. So we know that x equals 9 is indeed one of the solutions to this equation. Okay. All right. So let's try x equals 3. Okay, so here we have log base 2 of 3 minus 7 is equal to 3 minus log base 2 of 3 minus 5. Okay, and really we're already done. Okay, we're already done. We know this is not a possible solution because this will give us log base 2 of negative 4 equals 3 minus log base 2 of negative 2. And we can't take logs of negative numbers, so x minus 3 is not a solution. So x equals 9 is the only solution that is valid for this equation. Okay, let's move all of this down. Gonna need plenty of space here. Okay, let's take a look at another one. Here we have log base 5 of x minus 6 is equal to negative log base 5 of x minus 2 plus 1. All right, so let's go ahead and add log base 5 of x minus 2 to both sides of the equation. These will cancel, and we'll end up with log base 5 of x minus 6 plus log base 5 of x minus 2 is equal to positive 1. Now, using our quotient rule, or our product rule, which says if we add two logs together, we can combine them into one log, or we multiply the thing we're taking the log of together. So here we have, this is equal to log base 5 of x minus 6 times x minus 2 is equal to 1. Or we have, this can also be written as 5 to the 1 is equal to x minus 6 times x minus 2. All right, or just 5 is equal to this. So, or we can now write this as 5 is equal to x squared minus 2x minus 6x plus 12. Or we have 5 is equal to x squared minus 8x plus 12. And if we take 5 away from both sides, we will end up with x squared minus 8x plus 7 is equal to 0. Okay? Get yourself some more room. Alrighty. So now we want to find two numbers that multiply together to give us positive 7 and add to give us negative 8. I'm thinking we can do negative 7 and negative 1. So negative 7 times negative 1 is positive 7, and negative 7 plus negative 1 is negative 8. So we'll have x minus 7 and x minus 1 is equal to 0. Therefore, our possible solutions are x equals 7 and x equals 1. So remember, we have to check them. So let's see if we can just eyeball at least one of these right away. So we know right away before we even check it that x equals 1 is not going to work, because if we take x equals 1 and plug it into this part here for x minus 6, we'll end up with log base 5 of x, log base 5 of negative 5, which we definitely don't want that. So we know right away that that this one, x equals 1, is not going to work. So let's confirm, though, that x equals 7 is going to work. Okay? So we have log base 5 of 7 minus 6 is equal to negative log base 5 of 7 minus 2. Yeah, 7 minus 2 plus 1. And this is the same thing as log base 5 of 1 is equal to negative log base 5 of 5 plus 1. So let's add log base 5 to both sides. So we have log base 5 of 1 plus log base 5 of 5 is equal to 1. Now, using our product rule, we can go ahead and rewrite this as log base 5 of 5 times 1 should be equal to 1. Or we can rewrite this as 5 to the 1 is equal to 5 times 1, which is obviously true, okay? Because we have 5 to the 1 is equal to 5. So we know that x equals 7 is a valid solution for this equation. Right, so let's move these way down. And let's take a look at this one. But first, we want to look at a rule here really quick. So these are a little bit easier to solve. Here, if we have if log base a of m is equal to log base a of n, then m is equal to n. Now, again, this seems somewhat obvious, but this will be very helpful here in a second. So here, in this first one, we have log of 13 is equal to log of 5x plus 3. So if we let m equal 13 and n equal 5x plus 3, using this rule we just talked about, we can actually just ignore the logs here. We can more or less undo these logs, and we'll end up with 13 is equal to 5x plus 3. Okay, so let's go ahead and take 3 from both sides, and we'll end up with 5x is equal to 10. Can divide both sides by 5, and we'll get that x is equal to 2. But let's go ahead and make sure that this actually makes sense. So let's check. Let's check x equals 2. So we have log 13 is equal to log 5 times 2 plus 3. So we get log 13 is equal to log 13. Okay, seems obvious, but it's usually good to check. So there we go. X equals 2 is the solution to this equation. All right, let's take a look at this one. Here we have the natural log of x is equal to the natural log of x plus 5 plus the natural log of 2. Okay, so let's go ahead and let's see how maybe we want to do this. If we want to try and isolate all of the x's on one side, if at all possible. But maybe we can do that here in just a minute. Let's go ahead and take the natural log of 2 away from both sides. Okay, so here we have the natural log of x minus the natural log of 2 is equal to the natural log of x plus 5. All right, so using our quotient rule, we can rewrite ln of x minus ln of 2 as ln of x divided by 2, and this should be equal to ln of x plus 5. And now we can take advantage of this rule that says if log base a of m is equal to log base a of n, then m must be equal to n. So now we can just ignore the natural logs here, and we can think of this as, so then we have x divided by 2 is equal to x plus 5. Okay, so if we go ahead and multiply both sides of this equation by 2, then we'll end up with x is equal to 2x plus 10 after we distribute that 2. And we'll have then, if we take 2x away from both sides, we'll have negative x is equal to 10. We can divide by negative 1. And therefore we get x is equal to negative 10. So let's just confirm that this works. So I already see a problem here with this. And the problem is this ln of x right here as well as the ln, well, really everywhere that involves an x. Yeah, there's an issue here. So if we confirm, so let's check. Okay, let's check this. So we have ln of -10. This is an issue. So ln of -10 plus 5 plus ln of 2. Really, all this extra stuff is unnecessary. We already know there's an issue because ln of -10 is not defined, nor is ln of -10 plus 5 because we have the natural log of -5. That's an issue as well. Natural log of 2 is fine, but that was never going to be an issue. So since this was the only possible solution we came up with, and it's not going to work, we say that this equation actually has no solution. Okay, no solution. All right, let's go ahead and do one more. Here we have log base 3 of x minus 3 plus log base 3 of 2 is equal to log base 3 of 8. Okay, so let's go ahead and just use our product rule here. And we can write this as log base 3 of 2 times x minus 3 is equal to log base 3 of 8. Okay, so since we have two logs at the same base on both sides, we can now write this as 2 times x minus 3 is equal to 8. So let's go ahead and distribute this 2. So we'll have 2x minus 6 is equal to 8. If we add 6 to both sides, we'll get 2x is equal to 14, and dividing by 2 will give us x is equal to 7. Okay, so let's see if there's any issue here. Let's confirm that this actually works as well. So if we have log base 3 of 7 minus 3 plus log base 3 of 2, should have log base 3 of 8. So if all of this checks out, then we should be good. So this will become log base 3 of 4 plus log base 3 of 2 is equal to log base 3 of 8. But really this is, using our product rule for times 2, should be equal to log base 3 of 8. So therefore we have log base 3 of 8 is equal to log base 3 of 8. So we know that x equals 7 is a valid solution.